Let's move ahead. Now the topic is reflection of light. This is a very, very important topic, and also it is a, reflection is a phenomena which you see every day, or even if you stand in front of mirror, the light is reflected from the mirror. If you are viewing any object, suppose I'm viewing this small remote. So the light is coming on the remote and it is reflected back, and my eyes are seeing the reflected light, which is enabling me to see the remote. Okay. So reflection is a very interesting phenomena, and we encounter it on almost daily basis. So let us discuss what reflection is. So the phenomena of bouncing back of light into the same medium by the smooth surface is called reflection. Okay, that means suppose you have a smooth surface over here, okay, and light is entering like this. It is again going back to the same medium. This is called reflection, bouncing back. It entered and it bounced back. It entered like this, then it bounced back like this. This is called reflection. Okay, see a very interesting picture over here. This picture depicts the effect of reflection. This is a clean, calm water lake over here at the bottom, and you have a very pretty mountain, a scenic view over here. So you can see the exact image on the water, right? This seems like an exact copy of this scenic view at the bottom on the water surface, and this is possible due to the reflection of the light. So this one interesting phenomena I wanted to discuss with you. If you happen to visit any hill station or the places that have a cleaner environment and clean water, you can easily observe this phenomena. Now comes the laws of reflection. Since we are talking about reflection, we must be thorough with the laws of reflection. We've understood what reflection is. We've seen one of the effects. Let us now discuss what is laws of reflection. The first law says that angle of incidence is equal to angle of reflection. Second law says that incident ray, normal ray to the mirror at the point of incidence, and reflected ray all lie in the same plane. Okay, let us see over here in the image. This is your angle of incidence. What is angle of incidence? Angle of incidence is the angle which the incident ray makes with the normal. Normal is what? It is the line perpendicular to the plane mirror or smooth surface at the point of incidence. So this is your normal, right, perpendicular to the surface. This is the pink ray is your incident ray. The angle between the two, this angle is your angle of incidence. Angle of reflection, this is the reflected ray. So the angle between normal and the reflected ray is the angle of refraction. What does the first law says? It says angle of incidence is equals to angle of reflection. That means theta 1 equals to theta 2. This is the first law. Second law, this is your incident ray, then this is your reflected ray, and this is your normal. All the three of them, they lie in the same plane. That is the second law. Okay. Now, these laws of reflection are applicable to all types of reflecting surfaces, including spherical surfaces. We have a great discussion ahead on the spherical surfaces. So, the laws of reflection you need to keep in mind is applicable to all type of surfaces that we are going to discuss, and also the spherical surfaces as well. Next, the image formed by a plane mirror is always virtual and erect. See, we are discussing the features of the image formed by the plane mirror. Okay, these are the features that we observe for the image formed by the plane mirror. The first is image formed by the plane mirror is always virtual and erect. Erect means, see, if this is the object, the pointed part is downwards and the blunt part is upward. If I see the same orientation, it is erect. But if I see the orientation of the image like this, then it is inverted. Okay. So, in the plane mirror, we always see the erect image, and you need to keep in mind that the erect images are always virtual, or virtual images are always erect. Okay. The size of the image is equal to that of the size of the object. The image formed is as far behind the mirror as the object is in front of the mirror. Suppose you are here. So, at the same distance, the image will be formed. Okay, these two distance will be same. Next is the image is laterally inverted. Okay, we'll understand what is the meaning of lateral inversion through this figure. See, this is your plane mirror, right? Now, what is lateral inversion? Lateral inversion means the physics was written like this on the t-shirt, in this way. Right? But what do you observe? The S was in the right, it has come in the left and it has inverted. So, left part goes to the right part and right part goes to the left part. That is called lateral inversion. Okay, there is a 180-degree rotation in the image with respect to the object. Physics was written like this on the t-shirt, but when you observe it on the mirror, it is laterally inverted. Left becomes right, right becomes left. That is called lateral inversion. This is a very interesting phenomena that we observe in the plane mirror.